Introducing a paired solution to the primary challenges in the wind industry today, the Department of Energy has recognized a need to increase the coefficient of power by increasing tip speed while decreasing noise and blade loading. Shrouded turbines provide greater power output with a smaller visual impact than comparable open-rotor turbines. They do this by directing increased mass flow through the rotor plane. Scientist Albrecht Betz determined that an open-rotor turbine is limited to capturing no more than 59% of the energy in a given column of wind. This is because the wind hits the rotor plane as an impediment to the flow. Some of the wind flows around the impediment. A shrouded turbine uses a ringed airfoil to pull more wind through the rotor plane and then to dispel that spent wind downstream. The shrouded turbine theory also works when the ringed airfoil is downwind of the rotor plane. It's this action downwind that increases the mass flow through the rotor plane. Shrouded turbines are heavier than open rotor turbines, more expensive, and they create a large amount of drag force that results in stress and strain on structural components. The ideal turbine will provide all of the aerodynamic benefits of a shrouded turbine without the weight and mass of the shroud. The Keeley Virtual Shroud Rotor is a rotor blade that maintains the contour of the shrouds at the blade tip. Viewing this contour as a homogeneous annular form, the effect is a virtual shroud, providing the aerodynamic effect on the flow through the rotor plane without the expense and mass of the shroud. Each blade carries only the part of the shroud needed to bring greater mass flow through the rotor plane. A semi-shroud is a portion of a ringed airfoil surrounding the lower 10 to 50% of the rotor plane. The result is a 40% increase in the coefficient of power, a 20% increase in the tip-to-speed ratio, while decreasing tower signature, the low-frequency pattern of sound that is most bothersome to people. Obvia's combined innovation offer a 40% increase in the coefficient of power with reduced blade loading, reduced noise, and a lower cost of wind energy.